Hey everybody, welcome back. Last time I made a video demonstrating this random sequence generator I made using an Arduino Nano, and I just wanted to make a quick follow-up to explain what's going on exactly and how to make your own. It was a pretty easy build. You just need some jumper cables, a pot, a MIDI jack, some resistors and a couple switches. I was actually planning on adding a rotary selector to set the sequence length, but I couldn't fit the selector on this breadboard. It's a pretty annoying shape, and yeah, this works just fine. We just use this white jumper cable to set this sequence length, and that works for now. Of course, if I do end up putting it in the case, I will mount the selector, but this works for now. So I will put the schematic, the fritzing picture thingy, the code, parts list, everything in the video description and in the pinned comment. So if you just prefer that and you know enough about Arduino, then go ahead. But if you're pretty new to this, then yeah, stick around and I'll explain some of the basic stuff that's going on. So I'm using this Arduino Mini. I mean a Nano, of course. I got a few from China. They were very cheap, and I really like the fact that you can run them from 3.6 to 10 volts. That makes it very convenient for me. I can just use 4 AA batteries or 9 volt or a single 9 volt battery. I believe that the normal legit one runs from 9 to 12 volts, so you should be able to use a 9 volt battery, but I think it drops below 9 volts pretty quickly, so I'm not sure how long it'll last. And yeah, I just like the fact that I can use AA batteries. I'm not a big fan of 9 volt batteries because it's a bit annoying to find a 9 volt battery charger. By the way, I got the flu, so if you see a lot of jump cuts, that's just me cutting out a lot of coffee. So here we have these two black wires. That's just a couple of ground rails. You need a ground here for the MIDI jack, and you need ground for these pins that I want to use. So I just connected those to those rails. I put some of these little jumpers here to connect the rails. We also have a red wire coming from the 5 volts that supplies power to this spot here to the jack, and that allows the switches and the pins all to work. Then here we have a pretty neat little breakout pot meter, or potential meter I should say, thingy here. It's pretty cool. Normally you just get the pot with these 3 legs, but they put it on a little board so you can prick it in the breadboard. They even labeled, I don't think it'll focus, but the one on the left should say ground, the middle is out, and on the right is VCC. VCC is voltage in, out is the output, and ground is ground, of course. So you can just connect the 5 volts to one pin and out to an analog pin here, like I have it connected to A7, and then you can just read a value from the spot. It's pretty neat. That allows us to control the speed. You should be able to just use a normal pot, of course, but I don't think it'll play nicely with the breadboard, partially because of the angle, and I think you'll just ruin it. So these are very nice, but if I ever end up putting it in a case, I'll just use a normal one. I don't actually think the value will matter. It's a 10K pot. I also don't know if it's linear or if it's logarithmic, but I don't think it really matters too much. Just use what you have lying around. It's a fun little project. I'm not taking it all too seriously. So here we had the aforementioned 5 volt coming out to this plus rail. And then here I have a 10K resistor, I believe. I'll correct it on the screen if that's not correct. And that's going to this white cable that we use to set the sequence length, and it's also going to this orange cable, and then it's going through both of these switches. Now this is all a little cramped. I'll take out one of these switches. Actually, let's take this one, and I'll quickly show you how these work. These are very cheap, very tiny. They're a little flimsy. I mean, they don't sit too tightly in there, but they feel strong enough. And if you put it to the right, then the right 2 pins are connected. If you put it to the left, then the left 2 pins are connected. So the orange is supplying 5 volts. And let's see where I should put this. Yeah, right there. And if I set it here, then it doesn't send power to this blue wire. But if I flick it and put it there, then it does. And this one is now not sending any power to the yellow wire right here. But if I put it this way, then it does. So it's a little odd. Of course, again, with different switches, I would do it differently if I put it in a case, but this works fine. It's compact, it's cheap, and it works. So here we have the pins. These are required to, well, this helps the Arduino detect how these switches are set, and if they aren't set, how do I explain this? Here I'm using some pull down resistors to make sure that if a voltage or power isn't sent to the pin, then it's being pulled down to 0 volts. So it detects a 0 or nothing. And if we do connect up either this wire or hit the switch, then it jumps to 5 volts, and that's a high signal, and it'll detect it, and in the code you'll see how that affects everything. So currently I believe that if we don't have this white cable connected, it's set to a 16-step sequence. I think this should be 4, that should be 7, and the one at the top should be 8. And yeah, that's pretty much it for the pins and the readout. Now, of course, on this side we have the MIDI jack. It's pretty neat. You can fit this on some breadboards, but it's a little crooked, and I'm kind of destroying it by putting it on here every time, but that's fine. These holes in the middle don't really line up with these holes in these rails, so it wants to go on a bit crooked, and it's all a bit annoying, but it's fine. So here we're supplying power to the MIDI jack. Oh, by the way, I didn't mention, I think this is 10k resistor, and these are all 1k. I'm not sure if the values matter a whole lot. I'm not even sure if you actually need them, but I was told that this is good practice, especially with cheaper microcontrollers. It can't hurt, and it doesn't take too much space, and they're really cheap, so you might as well use them. So back to the MIDI jack. Here it's connected to the +5 volt rail, and that's supplying power to this pin. Again, I'll put schematics somewhere. And it's going through this 220 ohm resistor to this 4th pin there. Then in the middle we have the ground. It's just ground connected to this rail. And on the left we have the signal. This is what the MIDI signal travels through this yellow cable, and that also goes through a 220 ohm resistor to the 2nd pin here of the MIDI jack. So the other end of this yellow cable is connected here to the TX, and that's generally used for serial communication. I have read that if you want to flash, or not flash, but if you want to write a different sketch or file or code to the Arduino, that you have to disconnect this pin. I haven't done it yet, I haven't had any problems, but it's worth keeping in mind. Maybe it's depending on the specific model, but when you write a program to the Arduino, that's a serial connection, and this is too. So TX is a serial output, if I understood it correctly, and that's just sending the actual MIDI data. So yeah, that's basically it. I'll try and put a couple screenshots in the video, because my screen recorder isn't working for some reason, of the official Arduino website, where you can find the Arduino IDE that you need to write to the Arduino. I will also add a screenshot and a link to the website where I found the driver for this specific one, because I don't know if I mentioned it yet, but you need a specific driver for these Chinese Arduino Nanos. I'm not sure if they use a different UART or why it is, but it's a bit. It took me a couple minutes to get it started, but yeah, I'll promise to add some decent instructions there. So yeah, that's it for today. Thanks a lot for watching. I'll keep you updated if there's another version coming. Currently, it's only playing notes from one specific scale. If you want to change the scale, then you have to do it in the code, but I might add another rotary switch that allows you to set one out of, I don't know, 5, 6, 7, maybe even 12 scales. The selector has 12 settings. So that would be cool. It also depends on what you guys want to see. If you have suggestions, leave a comment below. I'll have a look at them. Maybe you guys have some really cool ideas that I didn't think about. And if a lot of people request the same feature, then I'll definitely put it in here. So yeah, again, thanks for watching, and I will see you in the next one.